Welcome to our exploration of motion and measurement of distances. Have you ever wondered how people traveled in ancient times or how we measure the world around us today? In this video, we'll journey from the earliest forms of transport to the modern marvels of measurement. We'll see how our understanding of motion has evolved and why accurate measurement is so important in our daily lives. Whether it's the distance from your home to school or the journey of a spacecraft to Mars, motion and measurement are at the heart of it all. Let's begin our adventure into the fascinating world of movement and measurement. Long ago, people had no vehicles or even roads. They moved only on foot, carrying goods on their backs. As time passed, they began to use animals for transportation. This was a huge step forward, making it easier to travel longer distances and carry heavier loads. Imagine walking everywhere you needed to go with no cars, buses, or trains. Animals like horses, camels, and oxen became essential companions for journeys across land. These early solutions laid the foundation for all future developments in transport. Travel across water, ancient people used simple boats made from logs of wood. Over time, they learned to shape and join pieces of wood, creating boats that could move more efficiently. Interestingly, they imitated the streamlined shapes of fish, making their boats glide smoothly through water. This clever observation of nature helped improve water transport, allowing people to travel further and carry more goods across rivers and seas. Invention of the wheel was a game-changer in human history. Wheels made it possible to move carts and carry heavy loads with much less effort. Over thousands of years, the design of the wheel improved, and animals were used to pull these wheeled carts. This innovation transformed how people and goods moved, making travel faster and easier. Even today, the wheel remains one of the most important inventions ever made. Till the 19th century, people still relied on animals, boats, and ships for travel, but the invention of the steam engine brought a new era. Steam-powered carriages and wagons led to the creation of railroads, making long-distance travel much faster and more reliable. This was the beginning of modern transportation, connecting cities and countries like never before. 20th century saw incredible advances in transportation. Automobiles like cars, trucks, and buses became common. Motorized boats and ships made water travel more efficient. The invention of the aeroplane opened the skies to human travel, and soon electric trains, monorails, and even spacecraft became realities. Today, we can travel across continents and even to other planets thanks to these amazing innovations. Transport isn't limited to Earth anymore. Scientists have sent small wheeled vehicles called rovers to Mars. These rovers travel across the Martian soil, conducting experiments and sending valuable information back to Earth. They are carried to Mars by spacecraft, showing how far our technology has come in exploring new worlds. Knowing how far places are is important for planning our journeys. Whether you're deciding to walk, take a bus, or ride a train, you need to know the distance. Measurement helps us answer questions like, can I walk to school? How far is the market? It also helps us in many other ways, from building furniture to farming and even space travel. Before rulers and measuring tapes, people used parts of their bodies to measure things. The length of a foot, the width of a finger, or the distance of a step were common units. But this caused confusion as everyone's body parts are different sizes. Imagine trying to build something when everyone's foot is a different length. Because body-based measurements varied so much, people realized the need for standard units. In 1790, the French introduced the metric system, which provided fixed, universal units for everyone. Today, scientists and people around the world use the International System of Units, or SI units, to ensure measurements are accurate and consistent. The SI unit for length is the meter. 1 meter is divided into 100 centimeters and each centimeter into 10 millimeters. For longer distances, we use the kilometer, which equals 1,000 meters. These standard units make it easy to measure and compare distances, whether you're measuring a pencil or the distance between two cities. Different measuring tools are used for different tasks. A tailor uses a tape to measure cloth, a carpenter uses a meter rod for wood, and a student uses a 15 cm scale for small objects. For measuring the girth of a tree or your chest, a flexible tape is best. Choosing the right tool ensures accurate measurement for every job. In measuring, it's important to place the scale correctly along the object. If the scale's 0 mark is broken, start from another full mark and subtract the readings. Also, make sure your eye is directly in front of the measurement point to avoid errors. These small steps help ensure your measurements are as accurate as possible. Let's try measuring with our own bodies. Use your foot to measure the length and breadth of your classroom. You'll notice that results vary from person to person since everyone's foot is a different size. This activity shows why standard units are so important for clear communication and accurate results. Another fun way to measure is using your handspan, the distance from the tip of your thumb to the tip of your little finger when your hand is stretched out. Try measuring the width of a table with your handspan. Again, you'll see that everyone gets different results, reinforcing the need for standard units. If you don't have a ruler, you can use a piece of string to measure lengths. Mark 2 points on the string and use it to measure objects or distances. For smaller measurements, fold the string into halves, quarters, or eighths. This method is handy when you need to measure something that's not straight or is hard to reach. Measuring a curved line like the edge of a table or a winding path can be tricky. The best way is to use a thread. Lay the thread along the curve, marking the start and end points. Then straighten the thread and measure its length with a ruler. This gives you the exact length of the curve. Motion is simply a change in the position of an object over time. If something moves from one place to another, it's in motion. If it stays in the same spot, it's at rest. For example, a bird flying is in motion while a table sitting in a room is at rest. Observing motion helps us understand how things move and interact in our world. Look around and you'll see motion everywhere: people walking, cars driving, birds flying, and even the hands of a clock moving. Some objects, like a table or a house, stay at rest. Others, like a butterfly or a train, are always on the move. Noticing these differences helps us classify objects as being in motion or at rest. When an object moves along a straight line, it's called rectilinear motion. Examples include a car driving down a straight road, a train on tracks, or a sprinter running a 100-meter race. Rectilinear motion is the simplest type of movement and is easy to observe in everyday life. Circular motion happens when an object moves in a circle around a fixed point. Think of the blades of a fan, the hands of a clock, or a stone tied to a string and whirled around. In circular motion, the distance from the object to the center stays the same throughout the movement. Periodic motion is when an object repeats its movement after a fixed interval of time. Examples include a pendulum swinging, a child on a swing, or the strings of a guitar vibrating. Periodic motion is important in clocks, musical instruments, and many natural phenomena. Sometimes, objects can have more than one type of motion at the same time. For example, a rolling ball moves forward, rectilinear motion, while also spinning, rotational motion. Many machines and natural objects combine different motions to function effectively. By measuring the distance an object travels over a certain period of time, we can determine how fast or slow it is moving. This is called speed. For example, a snail moves slowly while an airplane moves very fast. Understanding speed helps us compare different types of motion. Measurement is everywhere in daily life. A tailor measures cloth to make clothes, a carpenter measures wood for furniture, and a farmer measures land for crops. Even at home, we measure ingredients for cooking or the height of a child. Accurate measurement makes life easier and more organized. Even with standard units, small errors can happen while measuring. Maybe the scale isn't placed correctly or your eye isn't at the right level. These small mistakes can lead to slightly different results. Learning to measure carefully helps reduce these errors and improves accuracy. Using a measuring tape made of elastic material like rubber can cause problems. The tape can stretch, giving different results each time you measure. This makes it unreliable for accurate measurement. That's why we use tapes and scales made from materials that don't stretch or change shape. Try drawing a map of your classroom and rolling a ball on the floor. Mark where the ball starts and stops and trace its path. Or measure your foot with a string and compare it with your friends. These activities make learning about measurement fun and practical. Let's recap what we've learned. Different modes of transport have evolved over time, from walking to spacecraft. Measurement began with body parts but now uses standard SI units like the meter. Motion can be rectilinear, circular, or periodic, and sometimes objects combine different types of motion. Accurate measurement is essential in science and everyday life. Motion and measurement are all around us, shaping the way we live, travel, and understand our world. From ancient times to modern technology, our ability to measure and move has transformed society. As you go about your day, notice the different types of motion and think about how measurement helps us make sense of it all. Keep exploring, keep measuring, and keep moving forward.